All right. In theory, we're live. Hey, everybody. Welcome to a special double feature of open space. Being the brilliant guy that I am, I let my guests choose their interview time. And so today's guest is Australia's Fred Watson, and he chose 6 o'clock, exactly after this episode of Open Space. So I'm going to be going for 2 hours. I feel like a Twitch streamer at this point. But yeah, so we'll do an hour, regular hour of open space. And then after we finish that, we will do a follow-up hour of an interview with Fred Watson, who is a very accomplished space science communicator, PhD astronomer, professor. And we will talk about all things space, and you'll get a chance to answer all of those other questions, or ask all those questions as well. I want to remind everybody, or try to get everybody into the habit, which I try to get through as many questions as I can during the live open space. It takes, it looks like I'm getting through about 20 questions per episode. And obviously we're getting many more questions than that. So if we get through the show and I don't get a chance to answer your question, please put the question just into the comments of the video itself, because the live chat that's going by really quickly, it just disappears into the ether. And but if you put your question into the chat, into the comments of the video itself, then when I'm preparing my weekly question show, I can look through those questions and try to tackle some of those questions if I didn't get to them in the episode. So just keep that in mind, that if we didn't get a chance to get to your question during the open space, then we can go from there. But the purpose of open space really is to talk about what's happening kind of on the cutting edge of space and astronomy. Remember that my day job, my actual job, is to lead a team of writers and editors and multimedia people on Universe Today to report on all of the breaking news, all the interesting stories that are happening. So we will, while some of the question shows, a lot of people want to ask sort of deeper, longer term questions. But in this, we can have a back and forth. So if I say something and that generates follow-on questions, then we can do more. So let's keep going. Anyway, so that's sort of the gist of open space. If I don't get a chance to answer your question during the hour and you still would love an answer, put it into the comments of the video itself, and then hopefully I will get a chance to dig up some of those. I've got a bunch of guest answerers that I'm lining up, so you never know which famous person might answer your question, not just me. All right, so let's get into... congratulations to everybody at CosmoQuest for the amazing Hangout-a-thon. If you missed that, I had a wonderful debate with Dr. Ryan Watkins about whether we should be sending humans to the moon or Mars. It was a lot of fun. We talked about Olympic sports that could be held on the moon and Mars, where dogs would be happiest on the moon or Mars. So it was a pretty fun conversation. So you should definitely check that out. And I'm complaining about 2 hours, as Nancy is saying. Pamela and team went for 36 hours. So I've got to just suck it up here. All right, let's get into the questions for today. Colin Wright, didn't get a chance to ask this when you had your last guest from SETI on. Do you think that SETI has a long-term plan to shift focus towards exomoons in terms of looking for ETs? So for people who don't know, an exomoon, of course, is a moon orbiting around an extrasolar planet. And the reason why these are kind of interesting is that you could find, say, a Jupiter-sized planet orbiting around a star and go, well, that's, it's not going to be any life on that planet. But if the planet is orbiting within the habitable zone of its star, then the moons that are orbiting around the planet could be a giant planet, right? If you took Jupiter and pushed it into the inner solar system and had it at the same orbit as Earth, then all of the water would melt on Europa and Europa and Ganymede and Callisto. Io would still be a volcanic nightmare, but the rest of them would melt and they would be water worlds. So, and who knows, like the the light from the sun would vaporize a lot of the water on them, but I mean, Ganymede, for example, has its own internal magnetosphere. So there's some pretty interesting stuff that would happen if you moved a place like Jupiter into the habitable zone of its star. So up to this point, we see a Jupiter and go, well, that's just, there's no life there, obviously, right? You can't live on Jupiter, it's clouds. But there could be life on the moons. And so if you could detect terrestrial planets orbiting around giant planets orbiting around within the habitable zone of other stars, suddenly you've got all of these planets that were out of the running suddenly are totally in the running. Especially if you have like a world, like we look at Jupiter right now, and it has, whatever, 70 moons. Like we've all lost count, and we know it's going to be many more. It could be hundreds of moons orbiting around Jupiter, but 4 really big ones. Imagine a planet with multiple times the mass of Jupiter orbiting within the habitable zone. So now pretty much any world that is orbiting in the habitable zone of its star needs to be considered a potential place to look at for life. And so the search is on for these exomoons. And there's a lot of great researchers who I'm good friends with, actually, at this point, who are interested in exomoons. The challenge is observing them. At this point, exomoons have like maybe been detected once. And really just the technology is not there yet to make really dependable detections of exomoons. But I think it will absolutely be a huge field of study. In fact, way more exciting than anyone is giving credit today. Everyone's looking at terrestrial planets, but it could very well be that a planet orbiting, or a moon orbiting a giant gas planet like Jupiter, you've already got tidal interactions that are going to be giving you tidal flats. You're going to be giving you other encouragements for life. So actually, I think it's a really exciting field, and we just need better telescopes, better technique to be able to discover them. All right, Larry Beckham is asking, and a lot of people are asking this as well, Eric. Okay, so what's your take on the announcement from Sophia about water on the daylit side of the moon? So if you were like living in a cave for the last 5 days, NASA said they were going to announce something big on Monday about the moon. And I hate embargoed news releases. Like, for those of you who don't know, maybe I've mentioned this before, but on Universe Today, we don't look at embargoed news stories. My writers are not allowed to consider embargoed news stories. If you send us an embargoed news story, in other words, a story where you tell us secretly what the news is, but then we're not allowed to report on it for 5 days or 4 days or whatever, we delete it. And the reason is because it's a way to control journalists. That there's a lot of, in this modern age where it's really hard to, there's lots and lots of people who are very skilled at what they do, and they don't happen to be a member of the New York Times or Scientific American. Like, look at us, look at me, Universe Today. We're just bloggers. We started from nowhere, just writing space news, and we built up our credentials to the point that we could interview more and more interesting people. But I've had doors shut in my face that I'm not allowed to interview people. I'm not allowed to get access to information because I'm not a legitimate news source. Well, Universe Today is one of the largest space news sites on the internet at this point. We're not quite as big as space.com, but I think we're bigger than everybody else. So for the longest time, it was very frustrating. And so I don't want to try to promote a system that continues that process where like a university or a space agency gets to decide who's a journalist and who isn't, who gets the information and who doesn't. And it makes me really frustrated. And there's a lot of people that talk about like, well, you need the embargo system to give journalists time to prepare their story, to do behind the scenes coverage. No, you don't. You just don't. Any journalist who's been working in this field can digest the announcement of water ice on the moon by Sophia in an hour, to contact various people and get quotes and dig into this and look at journal articles and compare and contrast. So I think that the embargo system is, and then the other thing, sorry, is we get a lot of news releases where someone will give us a piece of news that I'm not super excited about. Like I just don't think it's news, and we wouldn't report on it for Universe Today, and it is considered embargoed. And so it's sort of like, ooh, it's special, it's embargoed. Oh, we get to be on the in crowd. We're the ones who know the embargoed news, and they're the people who don't know the embargoed news. And it creates a kind of an us versus them, and you feel an artificial incentive to report on it. So we don't do embargoes, we don't break them, but if you send us embargoed news, we just don't look at it until the news is publicly available out there on the internet. And we did that with the phosphine announcement on Venus. We were blissfully unaware of what was happening, and yet I think we've had great coverage of phosphine on Venus, and we're going to have great coverage of water on the moon. All right, so rant over, but just so people, because people always ask me, like, do you know what's going to be happening? I'm like, no, I don't. And if you told me, I would go, la, 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 stop telling me. I don't want to know until it's publicly available. So, and when it's publicly available, then we'll consider it as interesting news. All right, so let's get to the announcement. So, Sophia, which is the incredible, awesome aircraft, it's a 747 with a gigantic infrared telescope bolted onto the side. One of my favorite instruments out there. It's such a wonderful idea that you can fly this airplane up into the stratosphere, be able to get above a lot of the bad, the turbulent atmosphere, and perceive the universe in a wavelength that could only be done with infrared telescopes. And now suddenly you can see, and so you can keep this telescope perfectly stable, and you can observe parts of the universe that were only available to space telescopes. And so it's this great combination. I'm amazed there aren't more telescopes flying like Sophia. I mean, obviously you take a 747 and you fly for a long time. It's expensive and puts a lot of greenhouse gas, but the kind of science that they're doing is pretty impressive. So today they announced that they have detected water ice on the moon. And of course, we've known about water ice for a long time. India's Chandrayaan spacecraft, like a decade ago, discovered water on the moon for the first time. And over the last couple of years, we've seen more and more announcements of more and more water across the moon, mostly around the moon's south pole. There's clearly deposits of water ice under the moon. A couple of years ago, we saw that there was larger and larger detections of water ice mixed in with the regolith in some of the polar regions of the moon. And again, this is what you would expect. The parts of the moon at the top and the bottom are less directly illuminated by the sunlight, and they have a higher chance of being able to retain their liquid. And this is very important because when future explorers go to the moon, they're going to want to be able to refill their water bottles on the moon. And instead of having to cart all that water from Earth, be able to make rocket fuel, be able to make breathable atmosphere, be able to make drinking water, etc., water for growing your plants, you can just gather this stuff locally. And so the big announcement today was that thanks to Sophia, they were able to see the telltale signature, chemical signature of water mixed in with the regolith on the moon in the sunlit portions of the moon. And this is the surprise, because you would expect the radiation from the sun would be just drying out and vaporizing all of the water that's contained within the regolith. Now, it's not a lot. The math that I saw was that it was a 12-ounce water bottle. So let's say this much. I guess it actually is exactly this much. I mean, this is a 16-ounce pint, but like a glass of water in every cubic meter of soil, and that's about 1/100th the amount of water that's available in the Sahara Desert. So there's water, but it's not a lot of water. And so the question is, will there be some methodology later on that people can use to bake the lunar regolith to extract that water? Assuming that it's everywhere in certain latitudes of the moon, it makes it a lot more dependable as a source of water. Of course, this feeds in to the plans for the Artemis mission as when humans return to the moon, this is all going to be all about examining the polar regions of the moon and searching for usable resources that can support a long-term science habitat and maybe serve as a gateway to exploring the rest of the solar system. So, this wasn't a big surprise. If you'd asked me, I would have said they found water on the moon. That's what I was expecting they were going to announce, and they did it. And it's great news, and sort of feeds into this larger idea that the inner solar system is less dry than people used to think. So, it used to be believed that if you were within the snow line of the solar system, if you were within halfway point of the asteroid belt, then there was no water at all. Just the radiation from the sun just vaporized all water. And then if you're outside the halfway through the solar system, then you could have ice form. And that's why you've got places like Europa and Ganymede and Callisto and Enceladus and all these icy worlds out in the outer solar system. But people thought it was just this line in the solar system. And now it really turns out that there's actually a lot more liquid just inside the regolith of various asteroids and moons and various things, which means that, before it was sort of like desert, with Earth being the only oasis in the entire inner solar system. And now it looks like you can go to all these different places and find water. You're going to have to put in some work, but the resources are there. And that just means that future exploration, resource accumulation in the solar system is going to be a lot more, it's a lot more accessible. So the direction this story is going is really hopeful for the future of space exploration. All right. That was a long rant, I know, and I apologize for everybody who asked a whole bunch of questions in that time. All right. Larry Beckham, can the Spitzer Space Telescope target the moon, or is it dead? Spitzer is dead. Wah, wah. I don't know if Spitzer could have targeted the moon. I guess it could have. I don't know if anyone ever thought to do that. I guess we'll have to look that up. Vignesh Gopinath, unlike Mars, will Jupiter's magnetic field protect from the sun's radiation? If so, Titan would be the best place for colonization. Okay, so Titan orbits around Saturn, not Jupiter. So Jupiter does have a magnetic field, and it does protect from the sun's radiation. If you were standing on the surface of Jupiter, you would be protected by the radiation from the sun. The problem, of course, is that you can't stand on the surface of Jupiter. So you want to be on one of the moons of Jupiter. And the problem with being on one of the moons of Jupiter is that you're now bathed in the radiation. You think about the Van Allen belts here on Earth, which we know are a hazardous radiation zone that you want to get out of as quickly as you can. Jupiter has a Van Allen belt that's extreme. So just to give you an idea, if you're standing on the surface of Europa, just like taking in the incredible vista of Jupiter, just imagine you're standing on Europa, you're seeing Jupiter, and you're like, wow, that's amazing. You're also experiencing about 1,800 times as much radiation as you'd be experiencing just on the surface of the Earth. If you're on the moon, you're experiencing about 200 times as much radiation as you do on the surface of the Earth. So just standing on Europa, it's about 6 times as much radiation as just standing out in deep space, because Jupiter has this radiation zone that's around it that is just bathing all of the worlds around it. And the only one that's sort of got an interesting protection is Ganymede. It's the only moon with an intrinsic magnetic field, and we're not entirely sure what's causing it yet. So, but it could be a place that's maybe partly protected, but still, anywhere near Jupiter, very dangerous. In fact, the spacecraft that are sent in to visit Jupiter have to be hardened against the intense radiation, or they'll cause failures on the spacecraft. And a lot of the times when they're going in to examine some of the moons of Jupiter and stuff, they'll do these flybys where they will be farther out, and then they'll fly in quickly, do a bunch of observations, and then fly back out to get away from all that radiation. So no, you don't want to be anywhere near Jupiter. You don't want to be anywhere near Saturn. You don't want to be anywhere near any world with an intrinsic magnetic field. Wait, does Saturn have a magnetic field? I don't know. Put a pin in that. I'm going to look that up after we do this episode. Just to let you know, I watch these episodes after I do them, and then I look for all of the stuff that I didn't know the answer to, and then I learn them all. So hopefully I get smarter every time you ask me questions. All right. Arjun, Fraser can say sorry differently and go in, yeah, my Halloween costume. All right. Freya Pride One asks, how long can you survive that? So if you were if you're out in your spacesuit standing on the surface of Europa, you've got about a 50-50 chance of lasting a month, and you're almost guaranteed getting cancer after that. So just every day that goes by, you are getting more and more radiation exposure, and it will most likely kill you by the end of 30 days. Let's see. So, Avi Scott and Flower, do you know if NASA is already planning any space telescope around Starship? The guy from Louvoir you interviewed, maybe. So, I don't know of any official plans to use Starship. Starship is still, a pile of stainless steel which explodes from time to time and every now and then makes hops. So we are still years away from Starship being a proven safe vehicle that can deliver cargo to space. Look at the journey that it took to get the original Falcon 9 to fly. It took 10 years, I think, for them to start flying safely, repeatedly. Same thing with the Falcon Heavy. It took a long time for that to be a dependable vehicle. We're still 1 year into Starship prototype development. We just passed the 1 year mark. We saw a year ago, we watched the water tower fly. A month ago, we watched the grain silo fly. Hopefully in the next couple of months, we'll actually get a chance to see the new version, the one with the nose cone and the little flappy flaps and the 3 Raptors fly to like 20 kilometers altitude. The question comes in, can these things get back through the Earth's atmosphere and be safe? And it's probably going to be next year, maybe the year after that, before we can actually see that full test. And I've mentioned this many times. Like the moment that happens, everything changes. Like the course of space exploration goes in an entirely new direction, because now suddenly you've got a fully reusable 2-stage rocket system capable of delivering enormous amounts of mass to orbit in a fully reusable manner. So it'll be cheaper to launch Starship than it is to launch Falcon 9. Our imaginations are not prepared to deal with the ramifications of that. I just want to warn you, like we can't, it's really hard to predict what that looks like. What does it look like when you have a telescope that weighs 40 tons and you send it to space, and then the rocket returns to Earth and then grabs another one and sends it to space? So, anyway, but yes, some folks at NASA have done some sort of back of the envelope math for what kinds of payloads can go into Starship. And you could launch a much larger version of Louvoir, for example, which is this next generation telescope that comes after the Hubble Space Telescope. Or you could see a simpler version. And I think this is probably the direction they're going to go. So, they're going to design Louvoir at a certain point, and it's going to have a certain size. It's going to be whatever, 15, either 12 meters, 15 meters. I've heard a 20-meter version. But like James Webb, it's going to have a lot of this complicated folding technique to be able to fit it inside the nose cone of an SLS or whatever it's originally being planned to launch on. But you get a much larger nose cone. Now you don't have to have as many pieces that are folding out and articulating and extending. And so you could do a much bigger telescope. But, maybe you just go the other route and you just put and I forget the meter fairing of a Starship. What is it? 8 meters? So, 9 meters? So maybe just make a 9-meter telescope. Like when you look at telescopes like Herschel, a lot of these telescopes are built to perfectly fit within the fairing of the rocket and not require any kind of folding. The reason why James Webb was so complicated, has gone so far over budget, is that they went for a 6.5 meter primary mirror with an even bigger sun shield. And this whole thing has to be able to fold up inside an Ariane 5 rocket fairing, which is a standard, they're like 5 meters? Anyway, to fit all of that inside a standard rocket fairing and to be able to launch it. So you get a much bigger rocket fairing, and you can now either just make a bigger, simpler telescope. You could put a James Webb primary mirror inside a Starship, or you could build a much bigger telescope with very complicated folding. But I think that we're gonna move to space-based assembly of telescopes. I would say, I did a video about this like a year ago, and the direction that the costs are going, the prices are coming down to the point where space-based assembly, especially when you have something like Starship, is going to just dramatically change the way these telescopes come together. It's not going to be one telescope launched in one day. It's going to be pieces, telescope that come together bit by bit by bit, and they're manufactured like the International Space Station. Imagine if there was a telescope that was built with dozens of launches like the International Space Station, but it was one big space telescope. Just let your mind explore that idea. Simon Farmer, how much would it cost to make a duplicate of James Webb Space Telescope? A lot, still. I mean, you probably get a cost saving, because now you can just follow the blueprint of the original one. But if you wanted to make a duplicate, it would still run you in the billions of dollars, and it won't happen. Like, if James Webb is destroyed on launch, or if it fails to operate once it reaches orbit, I think they'll just move on. Like, it's too much baggage at this point have gone into building this telescope. It would be a nightmare. All right. Apologies for people listening as a podcast. By the way, all of the stuff that I do on my channel are all available as a podcast. So if you don't have time to show up live, or if you want to do something else, like go for a walk or something while you're listening, because it's just me talking, you should listen to the podcast. We have a link on Universe Today, or you can just do search for Universe Today podcast. All right. Romulus XC. Do you think it's possible to go to any of the solar system planets without gravity assist with direct space flight? So, yes, obviously, of course. All of the missions are sent to Mars without any gravitational assist. You just take a Hohmann transfer, go from Earth orbit to Mars orbit, and it takes you 9 months, and you get there. You can go to Venus. You can go even out to, say, Jupiter. The Juno spacecraft made I believe, a direct flight. I'm not sure if it made some flybys of Earth. The key is that if you take advantage of gravitational flybys, then you get to use a smaller rocket. You get to gain some velocity thanks to the flyby that you're doing. And so if you have less money to spend, if you don't want to use a space launch system to send your spacecraft into the outer solar system, and you still want to make it out there, then, and a good example of that, right, is like New Horizons. New Horizons used a gravitational assist from Jupiter. And even the better example was it the Galileo? So I believe it was Galileo was originally planned to be launched on the space shuttle, and they had a special booster that was put on it. And so the plan was launch it, release it from the space shuttle, use a super powerful booster, and head straight out to Jupiter. And in the end, with the Challenger accident, they had to change the launch vehicle, and so they couldn't give it enough of a boost. So they had to do a gravity assist of Earth and maybe Venus to be able to make it out to Jupiter. And so you could do the same mission just on a smaller launch vehicle by using those gravitational assists. So the downside of a gravitational assist is your mission takes longer. The upside is that you can do it with less energy. And so therefore it's cheaper. And so it all just comes down to, are you patient? If you're patient, then go the gravitational assist every time. If you really need that science done, then you go with a direct flight. But if you're going to go with a direct flight, then you need a much bigger rocket. It would be possible to chase down Oumuamua still if you put a very small spacecraft on top of a space launch system and maybe took advantage of a gravity assist. Although I don't know if you need one that's in the right direction. But anyway, so it's always, you've got all these options on how to get anywhere. And a lot of times there's people who spend, their only job at NASA is to work out these different orbital flight maneuvers to figure out which is the one that gives you the right balance of time and expense in terms of the capabilities of your launcher. Let's see. Again, apologies. Curious Borg, whatever happened to Juno? Is it still flying? Yeah, Juno is still flying. Once a month, we get a flurry of pictures from Juno of Jupiter. Beautiful pictures of the atmosphere of Jupiter, and then it heads back out to escape that radiation from Jupiter, and then comes back in. All right. Apologies again. Just looking for good questions here. Hold on. Curious Borg is asking, isn't Starship supposed to do a high hop this week before Halloween? I haven't heard that they are. The latest is that they did a static fire test of Starship's 3 Raptor engines, which is a more, this is the first time that you've had all 3 of the surface engines installed on Starship, and it fired, and that worked. It's had its flappy flaps installed, I believe that's the technical term, and the nose cone. So this is a version of Starship that is designed to hop to 20 kilometers altitude. When that's going to happen, I haven't heard an official date yet, but it's supposed to be very soon. I know Elon Musk mentioned at the Mars Society last week that it was going to be coming up very soon, but I don't know whether it's going to be like before Halloween, like in 4 days. That'd be amazing. I'd love it, but I wouldn't put your hopes. I would probably say we're still within a month or so. All right. Sias asks, hey Fraser, random question. Would it be possible to have an all-water planet or moon? Yeah, sure. You could have an all-water planet or moon. When you look at a planet like, or a world like Enceladus, it is almost, and I forget the exact number, it's like 95% water, right? That there are moons here in the solar system that are almost entirely water. Enceladus is like the shiniest, brightest place in the entire solar system. And if you brought Enceladus into the inner solar system close enough to the sun, then the whole thing would melt and it would just turn into this blob of water that was orbiting around the sun. Except it wouldn't be a blob of water, because you would have water under intense pressure from the weight of all that water. And you would also have heat inside, where the water being under this enormous pressure was heating up like the interior of the Earth. And so people have actually done some research into this, and unfortunately I don't have like all the numbers in front of me today, but it's thought that essentially you would have as you went down through this water, life could survive at a certain point in this water, but then you went too far down and then life wouldn't be able to, wouldn't get any light because the water would be completely dark, but there also wouldn't be any surface, essentially any chemicals. There wouldn't be volcanic vents that were throwing up material into the world. And so you would have essentially the inner rocky core of the planet would always be away from the surface water. And so in fact, it would actually be fairly sterile, even though it had tons and tons of liquid water. The key is that you need that mix. You need to have water, and you need to have some kind of volcanic activity that is throwing material into the water to feed bacteria and other life forms to begin this chain of life in a way that, you can have circulation and currents that are mixing this material together. And I mean, we don't have any examples of this yet. There's simulations, but we haven't actually seen a world that is a water world that we can actually study yet. And this is where you feel kind of sad, right? That even though our solar system is amazing, we've got Earth and we've got Mars, we've got Venus, we've got Jupiter, and we've got all these crazy places. As we start to learn more about the planets in the Milky Way, and as we start to discover other things, hot Neptunes, super Earths, hot Jupiters, mini gas giants, all kinds of things, exomoons we talked about before, we'll only be able to really run simulations. We'll never be able to study them up close and fly a spacecraft in orbit around a planet in the habitable zone that's entirely made of liquid water and look for life. So I always feel a little sad when I think about this kind of thing. Bill Sugden, how useful will the Gaia catalog be to amateur astronomers? I know some amateurs have very sophisticated setups. I'm not sure amateur astronomers will be able to get a lot of use out of the Gaia catalog. For people who don't know, of course, the Gaia spacecraft, like one of my favorites, is the spacecraft that is mapping out the distance, direction, speed of more than 1 billion stars in the Milky Way. It's actually like mapping out a 3-dimensional space of stars around us to give us a much better sense of just how the Milky Way works. And as an offshoot, it'll probably find tens of thousands of extrasolar planets. It's going to find, it's helped us figure out that there are probably 100 million white dwarfs in the, is that right? No, 10 billion, let me get this number right. 10 billion white dwarfs, 1 billion neutron stars, and 100 million black holes in the Milky Way. And so thanks to Gaia, we've learned all of these incredible things, but you need a spacecraft, or you need a telescope that's very, very good, like Gaia, to be able to detect the kinds of planets that Gaia is observing. It's looking for planets or stars which are tracing these tiny little circles in space because there's a planet yanking them around. And so you need to have a telescope that is as accurate as Gaia to be able to track these little stars that are moving around. So a lot of amateur astronomers have been able to confirm transit discoveries, say with Kepler or TESS. If you have any interest in doing that, you can actually confirm exoplanets for yourself with a small telescope. But I don't know if amateurs will be able to get a lot of use out of an astrometry mission like Gaia. Tofu Terror. Hi, Fraser. Expanding on the repercussions of James WST's destruction, how would its destruction failure affect how other programs progress? Would people be more fearful to make something like it again? Well, I think that the impact of James Webb has already been felt throughout the space science community. When originally it was called the Next Generation Space Telescope back 20 years ago, 30 years ago, people were starting to decide, work out the constraints of this telescope. Would it be like Hubble, but with a larger aperture? And they eventually settled on an infrared observatory that would be able to sort of peer back to the beginning of the universe, to be able to look through gas and dust. And then they worked out the size of the main mirror and then developed these various techniques for being able to lay out the sun shield, and everything would be able to fit inside a smaller launch fairing. And as we all know, the costs ballooned. And the reason the costs ballooned was because they put in a lot of uncertainty into the project. They were, whenever you work on a project, there are things that you know how to do, and there's things that you don't know how to do. And you want to be really careful about the number of things that you don't know how to do. And with a lot of missions, and this is why, for example, we don't see a lot of solar sails, and ion engines have only been started to be used in the last decade or so, even though the technologies have worked for a long time. you go with tried and true. You take a space hardened 486 and that's the brain of your satellite. You don't go with a brand new Threadripper. You go with something that's tried and true. So every time you introduce any kind of technical uncertainty into your spacecraft, you've got the possibility of incredible upside. You're going to suddenly be able to make observations that you could never make before. But things have a way of being more complicated than you thought. And add on top of that, dealing with an outside agency to deal with it, the big lesson that's been learned from James Webb and has already been felt is don't bite off more than you can chew, right? If you're going to work on a space telescope, prove that you are taking on a reasonable amount of uncertainty as you progress through this project. And so we see a lot of other missions that were started way after James Webb and have been completely, perfectly, beautifully on time, on budget, and launched. Look at TESS. TESS was delivered, I believe, even a little under budget, came exactly on time. You look at the Nancy Grace Roman telescope, used to be called WFIRST. It has, again, gone perfectly on schedule. All of the scientific instruments are ready to go. This telescope will almost certainly, unless the White House cancels it, this telescope will almost certainly launch precisely when it's supposed to. 2025? And there's a lot of other, you look at all the telescopes that are coming of the European Space Agency, they're all running right on schedule. One after the other. Cheops, Ares, they're all going perfectly. It's that James Webb took on too much uncertainty and the mission paid the price. And so my sort of sadness, my worry is that people will be too afraid, too conservative to take on big ideas. I mean, that's on the one hand, and it's funny, like think about yourself, even watching this as a community, right? You're like, why aren't there humans on Mars? Right? When you think about the uncertainties of putting humans on Mars, you've got like how are you going to deal with radiation? Where are they going to live? What are they going to eat? What are they going to drink? Is there fuel? How are they going to get home? Like the uncertainties mount up. You could probably just brainstorm a list of 1,000 uncertainties about sending humans to Mars. So on the one hand, you feel this way. And then on the other hand, you're like, yeah, but why did James Webb take so long? Right? Why are those people why do they even still have jobs that they did that? Well, they took on I think maybe 20, maybe less. I should figure out exactly what they were. There were they took on some uncertainty on the project and it got complicated and it got expensive and it took longer and everything had to be revised. And anyone who's worked in software has seen this happen a million times, right? This always happens. So if you're a space fan, just recognize those two instincts that you have in you. This should be happening faster. Why are people trying to be so aggressive? You gotta find that happy medium. And that's why it's called rocket science. All right, let's move on. Okay, so Arjun asks, how does a space company get on the radar of NASA so they can be taken seriously, so they can get support or even be used on a mission? Yeah, so NASA has a great system. They have a great way of bringing new ideas into the fold of future space exploration. And so they've got a few of these different ones. So one is called the Small Business Initiative. And so every year NASA puts out a list of all of the interesting technical challenges that they're looking to have overcome. And small businesses, it could just be a single person or people working at a university or a small company, can submit proposals to be part of the Small Business Initiative. And then NASA will award a bunch of small contracts out to these small businesses to develop some of these things. And so you'll have they need a new kind of pump, or they need a methodology for extracting water out of lunar regolith, or something like that. They also have a thing called NIAC, the NASA innovative, advanced concepts. And I go on and on and on about NIAC because they're the crazy out there ideas. And in that case, NASA's just saying, like, send us your craziest ideas and we will entertain them. And so you see ideas like methods of protecting astronauts from radiation, or being able to have astronauts hibernate, or missions to fly in the cloud tops of Venus, or a lot of that. A lot of the interesting missions that we report on Universe Today and on this channel come from these NIAC awards. And so they can be awarded $100,000 for an award. They can be awarded $250,000. And for phase 3, it's into the several millions of dollars. And so this is NASA just trying to figure out all of potential future technologies. And then they also have challenges. So if you actually go, I'm doing an interview with Christian Cottacini later on this week from HeroX. And so NASA does a bunch of challenges on can you develop a way to make pooping better on the moon, or can you have ways to shrink the mass of missions? And so it can be individuals coming up with ideas, or it can be small companies attempting to compete for these prizes. So there really is this pathway where small companies can develop innovative technology, they can show up, they can be folded into downstream other projects. And it's not just the giant contractors like Northrop Grumman and Boeing and things like that. There's actually a ton of smaller groups that are part of it. Corey S. is saying for all those small companies, there's ones like Bigelow that got screwed. There's a Bigelow attachment on the International Space Station right now. So, they got a pretty big contract to work with NASA. Neko Girl asks about the liquid water. I talked about that at the beginning of the show. Hal McKinney, I have no idea what you're talking about. How does typically self-annihilating quantum foam that pervades empty space ever have newly formed particles that persist, don't annihilate? If so, what types of particles persist? Okay, well, maybe I do know a little bit. So the only place, this idea of the quantum foam, this idea that there are this concept of these virtual particles, that there's just like virtual particles that pop in and pop out of existence all the time. And you can detect this as a Casimir effect. You can actually detect that these things are happening. It's just quantum fluctuations happening all the time. Do the particles persist? I don't know if the particles persist, but I think one of the ideas of quantum mechanics is that you can have, thanks to uncertainty, you can have particles pop in to existence randomly if you wait long enough. In fact, if you wait long enough, you can have a whole entire other universe appear and have a new Big Bang. You just have to wait a long, long time. I've actually got a interview that I'm scheduling with the author of the blog Not Even Wrong, and he's a particle physicist, so we will definitely be talking about that. I'll let you know when that gets scheduled. We'll be talking about particle physics and the kind of the current crisis in particle physics, and what are the interesting searches for dark matter and dark energy and things like that. So stay tuned on that. Save that question, and we will do it again. Again, I apologize. Sean Marson asks, "Hey Fraser, of all the types of stars that form, is there one that is more favorable versus another to form a habitable zone?" Love your show and thanks. So every star has a habitable zone. And a habitable zone is just the distance from the star where liquid water can be present. So the habitable zone around a red dwarf is very close to the red dwarf. The habitable zone around a planet around a star like the sun is about the distance from Venus to the distance of Mars. And so just however much output is coming out of the star, that changes the location of the habitable zone. But the question really is, Like, are there good habitable zones and bad habitable zones? And that comes down to a bunch of questions. So for example, if you've got the habitable zone around a red dwarf star, well, now you're really close to the red dwarf star. So you're almost certainly tidally locked to the red dwarf star in the habitable zone. So only one side of your planet faces the star and one planet is facing away, which is, it's not great, but it's not, it's not a deal killer. But the potential deal killer is the fact that the red dwarf is giving off enormous flares most of the time, and these are like 10,000 times more deadly than the sorts of flares that we have coming off of our sun. And so it would scour the surface of your planet that's huddled up super close. Remember, it's 10,000 times more powerful, or 100,000 times more powerful, and your planet is a fraction of the distance away from the star than what we have with the Earth and the sun. And then you have a place like the sun. Obviously, we have a habitable zone, that works. You could have a habitable zone around a star that has 20, 30 times the mass of the sun. It would just be farther out. But of course, those stars live very short lives. They're only going to live for a couple of million years, 10 million years at the most, and then they explode as a supernova. So that's, I mean, yeah, it's habitable, except that life doesn't really get a chance to form, and then the star explodes and wipes everything out. So that's not great. What you really want, the best habitable zone, is you want one where it's going to form around a star that isn't nasty. So, and you want the habitable zone to remain habitable for the longest period of time. And it looks like the best habitable zones are these K dwarf stars. So they're stars that are less massive than the sun, but more massive than a red dwarf. And they potentially will have a lifetime that goes, say, 70, 80 billion years, like 10 times as long as the sun, but they don't have that pesky flare period at the beginning of their formation. And so you could have a planet orbiting a star for, much longer than the length of the universe so far, all right? And just perfectly fine, just go on, and it could go for another, like if the star formed and planets formed around it, it's already been going for 10, 12 billion years, and it could still go for another 50. So it looks like those will be the most habitable stars for the long term, the best places to look for life. All right. Evie Scott and Flower, would I consider doing an interview with Angry Astronaut? I haven't watched any of Angry Astronaut's stuff. I'm assuming maybe have Angry Astronaut do a guest question show. Cody Zoe, does nothingness actually exist? So you're gonna, we did an episode on nothing. I'm not super happy with it, but you're gonna have to define what you mean by nothing. There's no place in the universe that there's nothing. Even, like, I'll give you an example, like in just a cubic centimeter, like the size of your pinky, there's about 400 photons, like just out in space. For every cubic centimeter space, there's about 400 photons from the cosmic microwave background flowing through it at all times. In a meter of space, there are about 10 atoms of hydrogen just flowing through. In a cubic kilometer of space, there's about 1,000 grains of dust. You're experiencing the gravity from every single piece of mass in the observable universe. There's energy. There's this quantum foam that Hal McKinney was talking about earlier. So there's kind of no place that you could go in the entire universe that has nothing. So I just want to remind you, as we're approaching the end. Hey, there you go, Hal McKinney. Yeah, Peter Voigt is the guest. He hasn't picked a time from my calendar yet, so it'll probably be next week, I think, at this point. So just remember, we're nearing the end of the show. I'm seeing that I've only answered a fraction of the questions. So please, if you want, I am begging you, take your question if I don't get a chance to answer it before the end of this and put it into the comments. And then that way I can grab up those questions and I can use them for future question show. Because honestly, because we've been doing a lot of the live stream stuff, there hasn't been a lot of good questions for the question show. It's been kind of hard to put together a question show. So if you've got good questions, please put them into the comments of the videos, and then I will gather a bunch of those up and also tackle them in question shows. My goal is to answer all you questions. I just need more time. K-Bear. When cosmologists talk about the universe expanding, does that mean that at the smallest possible scale, new pieces of space are being created? Or what is it that is actually happening? So when we say that the universe is expanding, a better way to describe it is that the universe is getting less dense. So the distance to the from galaxy cluster to galaxy cluster is increasing. And the classic example that always gets used is like raisin bread, that you put a loaf of raisin bread into the oven, and then the raisin bread expands, and all of the distance, the distance from raisin to raisin, no matter where you are in the raisin bread, gets farther away. If you're on any one raisin, you look at all the other raisins around you and they're all moving away from you. And so the universe is becoming less dense over time. When you think sort of expanding, then you're imagining a bubble that's inflating. Is there more space that's being injected into the universe? No, you're just having the volume that all of the stuff that's in the universe takes up contains a larger volume. The volume goes up, and the density of that stuff in the volume of space goes down. All right, I'm going to wrap up this episode just a couple of minutes early because, as I mentioned, this is a two-parter. This is a double bill, which as the second I wrap up this episode, I'm going to be doing another episode, and so with Fred Watson, astronomer from Australia, and so you're going to want to watch that too. So if you want to stick around and watch the next episode, but it's going to be on a different location, so you're going to have to go over to another link. So I'm going to be shutting this one down, opening that one up, and we'll keep going. And Fred is a PhD astronomer, so he'll be able to answer all the questions that I wasn't able to answer. All right, so again, if you want, throw your questions into the chat here, into the comments so that I can gather them up, or save them, and maybe we'll get a chance to answer them with Fred. Marty, you just got here, but that's okay. We're doing another hour, so just move over to the other episode. All right, we'll see all of you in like 3 minutes. Thanks, everybody.